Okay, so today we are learning about the area of regular polygons, and some of you took a look at this when we were reviewing for the test and said, hey, I totally can figure this out. Now, as we recall, regular polygons are polygons that have all sides the same length and all angles the same measure. And what you guys figured out was that all you have to do is divide regular polygons into triangles, congruent triangles, and you can find their area. So in order to do that, we're going to remind ourselves of the area formula for triangles. Area equals half base times height. And so we're going to take a quick look at some regular polygons and see how we can use the information that we know to find the area. Okay, so for example, I'm right now on page 565, and we've got a regular pentagon there. Okay, see that picture in green. Now, if you take a look at the bottom, the side length of the pentagon is 20 centimeters. Now, that side length is going to be the height of the base of our triangle. Okay, so all we need to do is put the number 20 where the base goes. And then we need to figure out the height. Now, unless they specially tell you the height, you're not going to know what the height is. So we actually, when we want to do a regular triangle, we need to find the distance from the side of the regular pentagon or the regular anything to the center of the polygon. That is going to be the height of our triangle. And by the way, if you take a look, I'm going to just draw with some pink right now. This is what it looks like when it's divided into triangles, okay? In a second, we're going to talk about how many triangles we have. But first, let's just understand that we have a triangle, we have a side length that we already knew about, and now we're given an extra piece of information, and that's the height of the triangle. Okay, so my next question is, how many triangles is this divided into? So let's just finish with this first problem, and then we'll think about that. So we identified the 20 as our base, the 14 as our height. We know that half times 20 is 10, and so 10 times 14 is 140. So we have one triangle that has an area of 140 square centimeters, and I'm trying to write just a little more neatly for you guys. Now, take a second while I'm writing this 140, and you tell me how many congruent triangles are in this figure. And because it is a regular polygon, you know they are congruent. Okay. So if you said 5 triangles, you are totally correct. Every polygon has a number of congruent triangles that is equal to the number of sides. 5 sides, 5 triangles. 7 sides, 7 triangles. 8 sides, 8 triangles. So each piece is 140 centimeters. There are 5 identical pieces. I'm just going to put this a little farther down since I'm apparently not writing small enough. And we've got 5 times 140 equals 700 square centimeters. Okay, so we are picking back up on page 566, so take a second, make sure you've gotten there, pause the video if you need to. So what kind of polygon is this? Let's figure that out. How many sides does it have? Okay, it is, as you said and as you noticed, if you've got your highlighter, it's a hexagon, right? That means it has 6 sides. So what we've just discovered is that from the center to each vertex, we can make 6 congruent triangles. Now, in order to solve the problem, we need to know the side length and the length of this line that is perpendicular to the side, that is the height of these 6 congruent triangles. So they have to tell us, we've got our unpleasant decimals, but we can handle them. We've got our side length of 4.2. We have our height of 3.6, okay? So we have 6 congruent triangles, and we're going to find the area of one triangle first. And so we're going to do 3.6 times 4.2, and we're going to be so careful. I saw even on the test, some of us were still having difficulty with the decimal places. So we all know that 3 times 2 is 6, but we've carried that 1, so we've got a 7. And now don't forget our placeholder 0 when we make mistakes. That's one of the places that we make mistakes. Okay, we get rid of that old 1 and we put that 2 in its place. Okay, and if the decimal multiplication is still giving you trouble, come to Math Lab. Okay, so now we have an answer, and 3 times 4 is 12, so the fact that we got an answer of about 15 is much better than our answer of, like, for example, 150. So now we know that it is, oh, this moved, it is 15.12 square meters for one hexagon. But here's the thing, we're not done for one triangle of the hexagon. We're not done because how many of them do we have? We have 6 of them. So we do our area here times 6, and this we should be able to do. And we get 90.72 square meters. Okay, and if this is not making sense to you, we'll go over it with more pleasant numbers tomorrow in class in one of the activities, whereas some of us will try more challenging ones. Okay, so now in terms of using our reasoning, they just want to know how many congruent triangles in a decagon, right? So before I said the rule, so pause the video, make sure you can answer this question without me telling you, and then write the answer down. Yep, you guessed it. The answer is 10 because the number of triangles is equal to the number of sides. Now, could we use this in an irregular polygon? Yes or no? Well, so the answer is basically no, because we're using the side length as a base, and each one is different. And the triangles are not congruent, right? They don't necessarily have the same height. So basically, if it's irregular, we just can't use this method. Okay, we are at the bottom of page 566 now, and what we are going to do in class tomorrow is a lot of practice and some nice challenge for some of you. Okay, have a great day. Bye-bye.